Hi everyone, this is Miss Afric here. Today we're going to be talking about solving linear equations and inequalities. But before we can talk about solving an equation, there are some prerequisites to that. So kind of important skills that we need to know in order to help us solve equations. Alright, so we're going to talk about two main things. One of them is written here, order of operations, and the other one is combining like terms, which is not written down. So feel free to write it down if you'd like to. Alright, before we get to actually doing a problem, let's talk about some vocabulary, because math in itself is kind of a language of its own. Alright, so it's really important that you know how to speak the language, otherwise when we're talking in these videos or when we're talking in class, you're not going to know what your teacher's saying. So, terms. When we call something a term is a part of an expression that's separated by plus or minus. So for example, if you have an expression that looks something like this, right? We could refer to 2x squared. That would be a term because it together, there's no plus or minus within that, right? So that makes it its own term. Or negative 3y, that would be another term. So those are individual terms, all right? Coefficient, the coefficient is the number that's multiplied with a variable. So for example, if I had a term of 10x in a problem, right, my coefficient, which I like to abbreviate, would be 10. Okay. Another important vocabulary, like terms. Right, like terms are terms that have the same variable part, and therefore we can add or subtract them. Or in other words, sometimes we just refer to those two operations as combining them. Right. So for example, some like terms, if we had 5x squared minus 2x squared, because they have that same variable part, they're both x squareds, that means that I can add them. And to add them, we just have to add the coefficients. 5 plus negative 2 or minus 2 would be 3, and then we keep that variable part. Alright, just to give you another helpful hint, a non-example. So if I had maybe 10 minus y. Alright, y is the variable part here, and my 10 doesn't have a y. So since they don't have the same variable part, you can't combine. Sad, I know. Alright, so that's really important to remember. And then the last important thing is order of operations, and that's necessary when we just have numbers. So there are no variables, just numbers. You can make a note of it if you like. I'm not going to write it down. And that tells us what order to complete those operations in. So maybe you guys remember it as PEMDAS, parentheses, exponents, multiplication and division, and addition and subtraction. Important thing to remember, multiplication and division, see how I wrote them on the same line? That's because it doesn't matter multiplication versus division. Alright, division can come before multiplication. All that matters is you start from the left of your expression and move to the right. And same with addition and subtraction. So for example, actually, we're going to do an example right below. Well, not right there. Over here. Okay, so take a look there for an example. So notice how in number 1 it says evaluate the expression. This one only has numbers. That's how you know, oh, I better think about my order of operations and do it that way. So order of operations, I like to write it off to the side just to remind me. Alright, order of operations tells me to do my parentheses first. So I see parentheses here and here. And since there's multiple pieces inside the parentheses, that's how I know there's something to do. So 2 times 3 minus 4, that's negative 1. Feel free to use your calculator if you need to. I know it's early in the year, you might not remember some stuff. Don't worry, you'll get better at it. And then my other parentheses, actually, notice how there's multiple things happening here. So because I have 2 different steps, I have to go back to my order of operations to figure out which one to do first. Well, there's multiplication and subtraction. Multiplication comes before subtraction, so I'm going to do that part first. That'll give me 8. 4 times 2 is 8. Then I can subtract 1, which gives me 7. Alright? Even though there are still parentheses in the problem, remember that we've done everything we can inside of them. That's how we know we're done with parentheses. Then I do exponents, negative 1 squared. Since it's in parentheses, negative 1 times negative 1 is positive 1. so no more exponents. And then multiplication and division. Remember, that could be division and multiplication. All that matters is you go left to right. So the first thing, these parentheses here mean multiplication, so 2 times 1. That's the first one I'm going to do. And then subtraction, I'm not there yet, so I keep going, and I see some division. So that means I'm doing negative 5 divided by negative 1. Well, that's going to be a positive 5. Right? Notice how I didn't make this multiplication. Technically, when we subtract, we're still adding, so if that subtraction sign goes away, you just bring the addition sign down. And then lastly, again, addition, still not there yet, but I do see a multiplication here, 5 times 7. That would be 35. So now I'm done with my multiplication and division. Last step, addition and subtraction, 2 plus 35 is going to be 37. So there's my final answer. All right, number 2, it says simplify the expression. So simplifying, that means combine like terms. Right? You'll know the difference between using order of operations and combining like terms because in this problem I have variables. Well, if I try to use order of operations with variables, I'm going to say, well, y plus x, I can't add those. And then you're stuck. All right? So instead of completely simplifying this down to just a number, we're just going to try and make it look a little bit neater. So to do that, I'm going to distribute these coefficients outside of the parentheses. So I get negative 8y minus 8x, and that's negative 2 times 3x, so negative 6x, and negative 2 times negative y, so positive 2y. And now that I've done that, I can look for my like terms. Remember, that means they have the same variable part. So I see a y here, and this one also has a y, like terms. So it's negative 8 plus 2, which is negative 6. Keep the variable part. And then I have an x here and an x here. Those are exactly the same variable parts, so I can add them. Negative 8 minus 6 is negative 14. And since these have different variable parts, I can't keep going. That's as simplified as it's going to get. Alright, so now those are going to help us to solve equations. So just a few more pieces of vocabulary to throw at you. An equation, that's a statement in which two expressions are equal. So if you're given an equation, for example, this, just a random one off the top of my head, when you see that equal sign, that means that those two the left side and the right side, have to be the same. That's what equals means. Alright, a linear equation, an example of that, an equation that can be written in the form ax equals b, well, like the one up here, and the one in number 3. Okay? But more importantly, let's talk about a non-example. So something that's not a linear equation would be if you have maybe an x squared in it. Alright, that would be no good. If you have an absolute value in it, that's not something we want. Okay? And then a solution is a number that, when substituted into the equation, makes the statement true. So if I gave you, for example, x minus 4 equals 3. Well, the solution would be the number that, if I took away 4 from it, would give me 3. Well, that number is 7. Right, so that would be my solution. Alright, let's try a couple examples. So when we're solving equations and there are multiple variables in it, remember that the first step is to get those variables on the same side so we can combine them. Alright, so here we're solving the equation and checking our solution. I see a 5x and a negative 2x. I can't have both of them there. I need to combine them, and in order to do that, they need to be on the same side. So I'm going to move one of them to the other side. I like to keep my variable on the left side. So I'm going to move this negative 2x to the other side. And since it's negative, in order to move it, I need to get rid of it from this side. And the only way to get rid of subtraction is with addition. So negative 2x plus 2x, that's 0. So now I'm left with nothing here but the plus 11. But over here, 5x plus 2x, that's going to give me 7x. Right. Now I'm just trying to isolate my variable. That means get x by itself. So I'm going to add 3 to both sides, and then divide by 7. And there's my solution. So that means that if I were to substitute 2 back in for both of these x's in the original equation, I should get a true statement, meaning 5 equals 5, or 0 equals 0. If you get something other than a true statement, then you either made a mistake when you were solving or substituted it in wrong. So that's what we mean by check your solution. All right, substitute it back in, make sure you're good. All right, number 4, I'm actually going to circle that one and save that for class. If you think you can do it on your own, feel free to try. It's always good to attempt problems. That way, if you get it right, you know you're good, and if you get it wrong, you can figure out what mistakes you're making so you don't make them again. All right, so feel free to attempt it, but otherwise your teacher will go over it in class. All right, now let's talk about solving inequalities. Solving inequalities is just like solving equations. The one super important difference is that when we're multiplying and dividing by a negative number, we need to flip the sign. We're so polite to you. Please flip the sign. That actually is, you must flip the sign. All right? So make sure you do that if you're ever multiplying and dividing by a negative number. Let's see what that would look like. All right? Number 5, it says solve and graph. So to solve this, I'm going to treat it just like an equation. The only time where we have to do something different is if I multiply or divide by a negative number. So adding 9 to get rid of that negative 9, I'm not multiplying or dividing, so I don't have to worry about it here. 13 plus 9 is 22. But now, to get y by itself, I'm going to have to divide by 11. Ooh, well, dividing, that's something I got to pay attention to. Am I multiplying or dividing by a negative number? No. 11 here is positive, all right? So that means that I'm okay to not flip. The sign can stay as a greater than, and 22 divided by 11 is going to be 2. So my solution are all numbers greater than 2. And then to graph it, I like to plot 0 just to give me a frame of reference. And then that means 2 is 2 units to the right. Since it's strictly greater than, that means it doesn't have that little line below it. Right? It's strictly greater than. We do an open circle. And I want to shade the numbers that are greater than 2, so bigger than 2. That means to the right. All right, and there's my answer. Okay, let's try one more, number 6. So number 6, same thing, but we have 2 x terms, right? 2 variables. So I'm going to get them on the same side. Like I said earlier, I always like to get them on the left side. Just makes it easier to read. All right, 10x minus 10x is 0. 7x minus 10x is negative 3x. Adding 9, so I need to get rid of that, so I'm going to subtract 9. And I'm going to rewrite this over here, just give me more room. Okay, so now to finish getting x by itself, I'm going to have to divide by negative 3. Well, again, dividing, that's something we have to pay attention to then. Am I multiplying or dividing by a negative number? Yes, I am, because this 3 is negative. All right, so that means I need to flip my sign. And I always make a little note of it, because sometimes, even though I think about it, I forget to do it. And when I check over my work and I see that note, I can say, oh, did I remember to do that? It's just a kind of easy way to check. So x, I'm going to flip this greater than or equal to less than or equal to. And negative 21 divided by negative 3 is positive 7. So to graph it, I plot 0 and 7. Less than or equal to, that means close circle because it could be 7. And less than means shade to the left. So there's our answer. All right. Well, you probably can see that there's another section here, applications. And those are some important problems because what's the whole point of math except to apply it to something in your actual life, right? So these are probably some of the most important problems we do. So I'm going to save them for class, all right? Your teacher's going to go over them. Feel free to read them, and just like I said earlier with the last problem, feel free to try it. Okay, but otherwise your teacher will go over them in class. We went over a lot in this video, so please, if you have any questions, write them down or try to look back at the video and see if any of your questions can be answered by one more watch. All right, otherwise, we'll see you next time.